Another approach to reduce the dimensionality by combining features is to use multiple discriminant analysis, which seeks for a projection that best separates the data. We need to find a vector W that maximizes J of W. In the case of two categories, it is M1 minus M2 squared divided by S1 squared plus S2 squared. M1 is the mean of the projected points, and M2 is the mean of the projected points in class 1 and class 2 respectively. S1 squared and S2 squared are the within class scatter of projected points for class 1 and class 2 respectively. S1 squared plus S2 squared is the total within class scatter, and M1 and M2 are the mean vectors of the points in class 1 and class 2. Within class scatter, S1 squared can be rewritten as the product of W transpose S1W, and in general Si is the sum for all the points in the corresponding class of the product of X minus M1 should be Mi, and X minus Mi transpose the sum of the sum of S1 squared and S2 squared is the product of W transpose SW, and SW is the sum of all Si. In the case of two categories, then SW is S1 plus S2. So the optimization problem goes to this point. Find W that maximize J of W, and the numerator can be rewritten this way, and you can look at this from the previous slide. The solution can be written directly. In the case that the conditional densities P of X given each class follows a normal distribution with the mean vector mu I and equal covariance matrix, then this is the form of the solution. In general, when we have multiple classes, the within class scatter matrix SW is the sum from 1 to the number of classes of Si, and the between class scatter matrix SV is the sum from 1 to the number of classes of Ni, which is number of points in class I, times the product of Mi minus M and Mi minus M transpose. M is the mean vector of the data points, and Mi is the mean vector of the data points in class I. And this is the optimization problem. And the matrix W that maximizes the function of which the columns are the eigenvectors corresponding to the largest eigenvalues. Then the projection of the original points X using W would map the data from D dimensions to C-1 dimensions.